Below?
Below, yes. So 95% of the population had a level below the reference value. These were the only compounds that were above the 95th percentile in NHANES. Some people had one or more of these compounds detected in their blood, but the compounds that were detected varied from person to person, and no individual had all of these compounds detected above the reference value in their blood. In this investigation, we were looking for commonality. Are any of the contaminants that we tested above the reference value in most, if not all, of the participants that we tested? And the answer to this for our investigation was no. However, we did have some individuals that did have higher levels above the reference value, and smokers had the highest number of compounds detected. Having a value above the reference number means that your value is higher than the general population. It does not indicate the potential for adverse health effects to occur. In order to determine the risk for adverse health effects, we need a little bit more information about the chemicals, such as how much you were exposed to, how often you're exposed to, and for how long. This investigation did not provide all that information. Some of these compounds are associated with natural gas production, but they're also common in a lot of consumer products. Because of this, regardless of where we conduct testing, we cannot use blood data alone to determine where the exposures came from. The exposure survey helps us identify potential exposure sources, and our estimations are based upon, or we use that information to provide our best estimation of why these compounds were higher in some people. (2,5-dimethylfuran) is a biological marker that we use to confirm smoking status in our participants, and it was only detected in the smokers of the investigation. Benzene, toluene, ethylbenzene, xylenes, and styrene are collectively referred to as BTEX, and they're commonly found in cigarette smoke. The levels of these compounds were highest in the smokers that we tested, and there was a dose-response relation between the time since the last cigarette and the levels that were measured in the body. This table shows the results for the BTEX compounds with the number of people detected out of 28 samples and the number of people that had a level above the reference value for each of the BTEX compounds. Besides smoking, these products or these compounds are also commonly associated with natural gas production, and they're also found in a number of consumer products. When we remove the results for the smokers from the analysis, this is what we have left with a total of 23 people that we tested that were non-smokers. In this investigation, there's two ways that we could look at the data. The first way was by doing like this and look at, are there levels that are higher than the general United States population based upon the 95th percentile from NHANES? And in this investigation, we found based on the population, the answer was no. The second way is to look at, are there a larger number of people with detectable levels of these compounds in their blood compared to the general United States population? This graph is the percentage of samples with DTEX for DISH compared to the NHANES with 95% confidence intervals. And I know some of the graph is kind of small, so I'll just kind of walk through what's on the graph for you. On the bottom, we have the BTEX compounds, benzene, ethylbenzene, toluene, O-xylene, MMP-xylene, and styrene. Along the vertical axis, we have the percentage of DTEX, with the blue bars indicating the percentage of DTEX for DISH, and the red bars indicating the percentage of DTEX in the NHANES. As you can see in the graphs,
Excuse me, you need to slow down a little.
okay, I'm sorry. The blue bars indicate the percentage of DTEX in DISH, and the red bars indicate the percentage of DTEX in the NHANES, or the National Health and Nutrition Examination Survey, what we compared all the blood results to. As you can see, in most cases, the percentage of people that had detectable levels of these compounds in their blood was lower than the percentage of people that had detectable levels in their blood from across the United States. The only exception is styrene, the very last column, where the percentage of detection was slightly higher here in DISH. However, by looking at the 95th% confidence intervals, there was no difference between the two populations.
I've got a question. I just need to ask this. You're saying the national averages. Where were the samples taken in the nation to get these results?
Across the entire United States. It's meant to be a representative sample of the entire United States.
How many people sample that clear.
Yeah.
I'd have to go back and look up the results. I don't remember exactly how many people they tested, but it's a survey that they do every year, and they test people. The volatile organic compounds in blood is just a small part of the survey. They ask a whole lot of other questions as well.
Is this with or without the smokers?
This is with the smokers. This is all the data.
And then,
Excuse me, if we could write your questions on your card so that we can get through the presentation, that way everyone will be able to ask questions and we'll be able to hear them from the microphone. So I appreciate your doing that. Thank you.
Five people that we tested had levels of bromoform, chloroform, dibromochloromethane, or some combination of these contaminants at level in their blood at levels higher than the general United States population. These compounds are disinfectant byproducts called trihalomethanes and are associated with chlorinated drinking water systems. All five individuals were on the same tap water supply, and by looking at the blood and tap water data together, it's clear that these results are most likely due to the presence of these compounds in their drinking water. Although these five individuals had levels of the trihalomethanes higher than in their tap water, higher than the other people that we sampled, there was only one residence in which these levels, the levels of trihalomethanes in the tap water, were above federal standards. And I'll talk more about the drinking water data in a few minutes. One person had levels of tetrachloroethane, one person had levels of trichloroethane, and one person had levels of 1,1,1-trichloroethane at levels above the 95th percentile in Haynes. Based upon information we collected in the exposure survey, it appears that these results are due to occupational or some other exposure around the home. Two people had levels of 1,2-dichloroethane, and one person had levels of 1,4-dichlorobenzene at levels above the general United States population. We were not able to identify a likely exposure source for these results. Urine samples were analyzed for these four metabolites. Metabolites are substances the VOCs are changed to within the body. Data on the levels of these compounds in the general United States population do not exist. We do not have the similar information that we do for the blood data for the urinary metabolites. But to be able to do some kind of rough comparison, we use the results from several published analytical method papers, as well as from DSHS staff. DSHS staff submitted blood and urine samples before we left Austin and after spending a couple days here in Dish. The urinary results are being presented in a series of graphs, and I'm going to use this example of how to interpret the graph for those of you that might not be familiar with this type of graph. This graph is referred to as a box plot, and the shaded box indicates the middle 50% of the data. The line through the shaded box is the median, or the 50th percentile, where half of the values were above and half of the values were below. The top and bottom borders of the box are the 75th percentile and the 25th percentile. And the horizontal lines, or whiskers, coming down out of the box represent the maximum and minimum values that are no more than 1.5 times the range of values between 25th and 75th percentile. Individual points above the graph are referred to as outliers, and the statistical program that we use to look at this data identify these as values that deviate markedly from other members of the group. This is a lot of information on one graph, but the important thing to look at is where the median is, or this middle line through the box, and what the spread of the data shows. The next four graphs represent the levels of the urinary metabolites in this investigation. To kind of help you orientate on this graph, the first two, the horizontal axis are the 6 categories that we looked at. The first column is the results for the non-smokers we had in Dish. The second column